So let's look at another mass problem. So for example, let's find the mass of the Mia corresponding to the first quadrant portion of the circle x squared plus y squared equals 4, where the density at the point xy is proportional to the distance between the point and the origin. So the first thing we're going to do is look at our density function. We're told that the density function is proportional to the distance between the point and the origin. So the first thing we're going to do is look for the distance between this point here, xy, and the origin. Well, that's just our distance formula. So the square root of x minus 0 squared plus y minus 0 squared. And if it's proportional, that means that the density is a constant multiple of this. So rho of xy equals k, where k times that square root, where k is a constant. And so our density function is k times the square root of x squared plus y squared. Okay, so now we have our density function. We're going to want to remember that. Here's my density function. Let's go back up to our problem, and we now need to look at our region. We're inside this circle, but we just want the portion that's in the first quadrant. So it's a circle of radius 2. In the first quadrant. So this is the region that I'm talking about. And so since we're talking about part of a circle here, let's suggest maybe we should use polar coordinates here to describe our region R. So if we use polar coordinates, how do we describe this region? Well, theta is between 0 and pi over 2, and R is between 0 and 2. So to find our mass, it's going to be from 0 to pi over 2, 0 to 2. Now we do need to change our density function. In terms of polar, it'll be k, that's just a constant, square root, and then x squared plus y squared becomes r squared. And because we're switching to polar, remember we get an r dr d theta. So the square root of r squared, it's just going to be r. So this whole thing here simplifies to r, but then there's an r right there. So I'm getting m, it's the integral from 0 to pi over 2, 0 to 2, k r squared dr d theta. So go ahead and integrate, do the first integral. Kr cubed over 3 from 0 to 2. So that'll be an 8k over 3, which is all constant, so I can pull that out. So then I'm going to get an 8k over 3 theta, and then plug in pi over 2, so you'll get 4 pi over 3 times k. And this would be my mass. So if your region looks nice enough, if it, in this case it was part of a circle, you might consider using what we learned in the previous section about polar coordinates to help you compute this double integral.